Hi, my name is Karina Shah. I'm 15 years old and I'm a space tech enthusiast whose main mission is to make space exploration and inhabitation a reality. During one of my many deep dives into the current innovations and topics of research that are currently taking place within the space tech field, I came across CMEs, which in full length are coronal mass ejections. And essentially, these CMEs are large bursts of electrified gas that are periodically emitted from the sun's plasma and inner core, which is also known as the corona. In fact, when these CMEs are pointed towards the Earth, they're responsible for the auroras and the northern lights that we often see in our night sky. Unfortunately, however, what a lot of people don't know is that these coronal mass ejections threaten countless aspects of space exploration. And thankfully, our Earth is well protected from these CMEs due to one of its atmospheric layers called the magnetosphere. And the magnetosphere is the atmospheric layer that is responsible for making it harder for particles from the sun to penetrate into our Earth. So essentially, humans are well protected from these CMEs, but technologies both inside and outside of Earth are not. Most satellites orbiting Earth are communication satellites, and CME magnetosphere interactions can lead to geomagnetic storms, and these can make the satellites extremely charged, and it can ruin key components. Even electrical grids on Earth have an even higher chance of being damaged due to geomagnetically induced currents, which can greatly affect the conducive materials on Earth. Oh, and don't forget the astronauts in outer space who are under the constant threat of being hit and probably killed by these CMEs. So I decided to study and leverage pre-existing data from the Solar and Heliospheric Observatory satellite, aka SOHO, which was a satellite that was launched in 1995 with the sole mission of studying the sun's both internal and external structures. Till date, it still slowly orbits the sun around the Lagrange point L1. So here's how I did it. This is an example of an image taken from one of the coronagraphs on LASCO, or Large Angle and Spectrometric Coronagraph, which is a set of 3 coronagraphs that image the solar corona and was one of the instruments of the SOHO mission. In these images, you will see a black disk known as a occulting disk, which blocks out the disk of the sun and the inner corona. The white circle in the images outlines the size and the location of the sun. On the bottom of the image, there are tick marks which indicate the units of the sun's diameter. And to the right of the disk, there is a hazy whitish blob, which is the CME erupting from the sun. 5 of these images were taken at different timestamps. The next step in this process is to select a feature that is present in all 5 images. An example of this can be the outermost extent of the bright structure, which is the CME, or even the inner edge of the dark loop shape. Using the tick marks, you can then measure the position of the feature in each image. So what I did was, I chose the outermost extent of the bright structure, which was a CME. So the measurements on each image can be converted into kilometers using a simple ratio as shown. For reference, the diameter of the sun is 1.4 million kilometers. Using the time and position data you now have, the average velocity of the feature you have chosen can be calculated in a time interval. So the following equation gives you the average velocity v. Using the newly found velocity and time data that I collected, I then calculated the average acceleration of the feature I chose, which again was the CME. The following equation gives you average acceleration a. I then created a data table to record all of the data that I collected as shown below. My results are as follows. You can also repeat these measurements on another sequence of images from other CMEs. There's also an online catalog of CME movies available. Once you place a movie, identify where the CME occurs and scale the images using tick marks, as was done with the first set of images that I discussed above. With all of the data I collected on the various features of the CMEs, I was able to gain a better understanding of how these CMEs function and typically behave. If we are able to obtain this information and understanding, then we can predict potential CME interactions with satellites and other technologies that can be severely affected. And we can also prevent catastrophic events from occurring, such as widespread blackouts. Undoubtedly, satellites and technologies like SOHO are extremely important to understand and continue for our societies to remain stable and safe. And if we are able to constantly prevent these catastrophic events from occurring, we'll be able to sustain the human civilization for an indefinite amount of time. Space technologies and space exploration is the future, and I'm so excited to see how this industry will continue to grow in the near future. Thank you so much for watching, and I hope you